Okay, we can also do reduced row echelon form or Gauss-Jordan elimination very easily by using a calculator, and that's what we're going to go through now as the steps. And here they are. Use the steps below to solve the system to the left. So here's our system. First off, let's pull up our graphing calculator. Step number 1 says press second and then X inverse and the arrow to the left to edit. Choose a matrix to edit, input the augmented form of the system, then hit the second mode to quit. So here we go. Let's hit second. And we're going to our matrix menu right here. We're going to choose, let's say we're going to go over to edit and then choose whichever matrix we want to call it. And we'll just call it matrix A right here. So enter our, press our enter button. Then we're going to input the augmented form of the system. Now you have to tell which size it is. Now this thing is going to have 3 rows and it's going to have 4 columns. So we're going to do 3, enter, 4, enter. And then we simply input our matrix. And let me go ahead and do that. Okay, I've got it in now. Now it says, then hit second and mode to quit. So we're going to go second and then our mode button to quit and go back to our home screen. And again, we see here they have pictures of all the different things that we're supposed to be doing. Next up, we're going to go back into that matrix menu. Let me pull my calculator back up. It says press second, X inverse, and the arrow over to math now. So second, matrix menu. We're going to go over to math. We're going to scroll all the way down to the letter B, and it says RREF, which stands for Reduced Row Echelon Form. We're simply going to press enter on that. Step number 3 says press second, and again, go back into the same menu, and we're going to click the name of the matrix that we just created. So second, matrix menu, and there is our matrix that we just created. Hit enter on it. You can close parentheses if you'd like, and hit enter again. And there it is, and you're finished. It did reduced row echelon form for you. There's your identity matrix. So therefore, your solutions are -2, -1, and 6. Therefore, the solution, which you see here on step number 4, is going to be -2, comma, -1, comma, 6, which is much easier than actually doing that by hand. Okay, now let's talk about special solutions. From the previous lesson, you know that not all linear systems have a unique solution. You might have one solution as you have here, or you have other types. Linear systems can also have no solution or infinite number of solutions. The row echelon form of a linear system can reveal whether it has one, no, or infinite solutions. So this is an example of one solution, as like what we've been seeing. The matrix is written in reduced row echelon form with all zeros along the diagonal and then everything, or ones along the diagonal, zeros everywhere else. So you have solutions. Now, what does no solution look like? Notice that this bottom row right here, 0x, 0y, 0z is equal to 5, which pretty much is the same thing as 0 equals 5, which is a false statement. Anytime you have a false statement like this, then you will have no solution. So a row contains 3 numbers, or 3 zeros, and then a number as that last row. Now, an infinite number of solutions, if you look at that last row, it says that 0 equals 0, and we know that when we have a true statement, then we're going to have an infinite number of solutions. Okay, let's work some examples. It says, using your calculator, determine whether the system has one, no, or infinite solutions. Give the solution if it does have one. So let's go ahead and take our calculator, and let's enter our matrix in. Now, if you would like to clear out, anytime you want to clear your calculator out of all the matrices and stuff you have stored, you can always do second, the plus sign, which is the memory, and just type in 7, 1, and then 2, and it clears your entire RAM, and now everything is gone that you had saved. So you can go back into your matrix menu, and now notice that, again, there's no matrices. This, again, is going to be a 3x4 matrix, and I'm going to go ahead and pause and type our matrix in. And now that our matrix is in, again, we do second, quit, go back to our home screen, go back into our matrix menu, go over to math, go down to RREF, which is located at B, and we want a reduced row echelon form of matrix B. So go back into your matrix menu, or of matrix A, excuse me. Close the parentheses, hit enter, and notice your last row. says 0, 0, and 0 is equal to 1. If any time you have 0 equals to 1, then there is going to be no solution. Number 6, again, let's go ahead and we will just go and enter our matrix menu. Let me try that again. Go over to edit, and we'll just call this matrix B, and you can just continue naming these. You don't have to delete any of your old matrices unless you just want to. So let's go into edit matrix B. Again, a 3x4. Pause while we enter. And now that we have it entered, again, second, quit to get out of it. Second matrix, go over to edit, or excuse me, go over to math, go down to RREF. We stored this as matrix B, so I'm going to do RREF of matrix, go down to B, enter. You can close, but you don't have to close parentheses, and here's what you get. You get your identity matrix, everything's lined up, and you do have a solution, -2, -8, and -3. So you have one solution there. Number 7, we'll go ahead, again, the process is the same. I'm going to go ahead and pause the video. I'm going to enter my matrix, and we'll do RREF of that matrix. Okay, so now we have it typed in, and we are going to do the RREF. Go over to math, go down to RREF, and we call this one matrix C. So back into your matrix menu, go down to C, and here's your solution. Notice the last row says 0 is equal to 0. That's a true statement. So therefore, on this one, we would have infinite solutions. Okay, number 8. Again, let's type our matrix in and RREF it. And here is what you get. I want you to notice that you do have your identity matrix here, so therefore we will have one solution, and these 3 values represent those solutions, -7, 4, and 1. So therefore there is your solution. Number 9, doing the exact same thing. Let's go ahead and type our matrix in and hit RREF, and here's what you get. And again, notice that you have the 1s and 0s on the left side, so our solution is 2, 6, and -5. So therefore, you have one solution to that system. Okay, number 10, again, take your calculator. Let's type our matrix in and hit RREF. And here is what you get. Notice your last column, it's 0 equals 0, which is a true statement, so therefore that would be infinite solutions. Again, true statement, infinite solutions, false statement, no solutions. Okay, number 11, let's work the last 2. Go ahead and type it in, RREF, and here's what you get. So notice again in our last row, we have 0 equals 1, so now we have a false statement, so therefore that would be no solution. And number 12, the very last one, type your matrix in, RREF, and here's what you get. Now this one's a little confusing. If you look at that last row, a lot of people is going to say, oh, this has no solution, but you got to be careful because that last row, if you were to write it back as an equation, it says that 1z, which is right here, whoops, let me pull that up again. It says right here that 1z is equal to 0. So therefore z is 0. So we do have our identity matrix over here, and our 3 solutions are -1, -2, and z is 0. So therefore there's your solution.